let's say first quadrant, 7, no, that's 7 right there, no, that's 1, that's 7, that's 8, comma 6. Let's call this B right there. And I'm going to try to figure out, so our B coordinate is 8, comma 6. And if we do a half turn, it should become -8, comma -6. We just change the sign on the x and the y, -8, -6, -8, -6. I'm going to use pink for that one. -8 and -6 is located right here. Here's B prime, and it seems like it did a 180-degree rotation right there. So our hypothesis is probably correct, so that's our conclusion, that it actually worked. Okay. So my students have said, okay, let's look at this. I told my students, let's look at this from a mathematical point of view. If we take a point, x comma y, we did a rotation 90 degrees. We end up with, we flipped x into y, becomes y and x. We change the sign on the new coordinate of x. Let's do another rotation of 90 degrees. So we flipped it again. This became x, this became y, negative, it stays with the sign, and we flip the x, we change the sign of the new coordinate of x right there. So if we did a 90-degree rotation and another 90-degree rotation, it will do a 180-degree rotation, if that's correct. So our x, y coordinate became -x, -y, just like our hypothesis. So mathematically, it was sound as well as our observation and conclusion. So let's use the power of observation one more time to use a scientific method. It's not quite as rigorous scientific. The rigorous of scientific method can be quite rigorous, but for a simple example, you just started to get used to the scientific method. So we'll just kind of do a high-level overview of this scientific method. We're going to reflect about the x-axis this time. Let me bring it in just a little bit. Let's see if you can see it better. It's a reflection about the x-axis. Okay. Let's do the scientific observation one more time. Let's take the point 4, 2. Let's call this C. If we reflect it about this line, the x-axis right here, it should be, since it's in quadrant 1, the image should come out to be in quadrant 4. And so here is probably where the reflection is. So C prime, the image should be 4, -2. Notice it went 4 to the right and down 2 units. Okay? Make sure you get your x and your y coordinates correct on those. Students have a hard time trying to see, they put the x sometimes first and they're going in the x direction and then they actually put a negative in front, whatever. So be careful when you do these. Okay, coordinate. So let's look at our hypothesis. So 4 stayed the same, the x coordinate stayed the same, the y coordinate changed from a positive to a negative. Wow, okay. Let's see if that actually works or not. So our hypothesis should be something like this. X comma y does a mirror. Instead of R, a reflection, because R was used right here for rotation, I'm going to use the mirror about the x-axis. Okay? Sometimes they just call it mx, mirrored about the x-axis. Okay? And our hypothesis says that the x stayed the same and the y changed. That's probably going to be our formula. Let's test our hypothesis to make sure it works. We can pick a point in the third quadrant and it should mirror, according to here, if it's here, it should mirror to the second quadrant. So let's pick a point. -5, 6. Ooh, that's a bad color. Not gonna use green anymore. Gotta make buy some more highlighters. -5, 6. Okay, that's that point right there. Let's call this D, point D right there. So if it gets mirrored around the y equals x, x line or the x-axis, it should be in the second quadrant. Notice that it's -5 in the x direction, oops, and -6 in the y direction. Got to be careful with that. So it should have been -5, -6, -5, -6, and if you mirror that, it should come up in the second quadrant. And the x accordingly, let's do this using this one. Let's test our hypothesis. -5, -6 does a mirror about the x axis. Everything stayed the same except we change the sign from -6 to +6. Okay. -5, +6, there it is. That's D prime. Does it seem to be the fact that D, the pre-image, when reflected about the line y x-axis, turns out to be D prime? Yes, it seems to be the case. Okay, so that's our rule. Reflection about the y-axis now. About 20 minutes has elapsed. We're going to try to finish it up within 28 minutes. Since we did the mirror about the x-axis, let's do another hypothesis. About the point x, y, and we are going to mirror it about the y-axis this time. Pause it to think about what would happen if you mirror about the y-axis. The x and the y stay the same, and since the y value is changed about the x-axis, when we mirror about the y-axis, probably the x-coordinate is going to change. So it should be -x, y. That's our hypothesis, and let's test it. Okay. Let's pick a point. I don't care. Third quadrant, fourth quadrant. Let's pick a point in the fourth quadrant. It's going to be 4, -2. Going 4 to the right and down 2 units. So that's 4, -2. Let's call this point E. That's our pre-image. And then, and then we're going to mirror it about the y-axis. We bring it straight out. 4, -2. And now we're going to switch the x value from a positive to a negative. Let's see if that works pretty good. Where's -4, -2? -4, -2, there it is. And E prime is your image right there. Does it seem to be the case that it got reflected about the line, about the y-axis line? Yes, it does. Okay, great. So we have all of these different rules. If you memorize the x-axis, you should be able to recall the y-axis. If you did a rotation about 90 degrees, that's counterclockwise, you should be able to remember the -90 degrees. A half turn is just just putting the x and y, and whatever it was positive, you change the sign. Okay? Alright, so let's do one last thing. Rotation, is that it? Yeah. Reflection about the line y equals x. We're going to do a rotation about a certain point, and maybe do some, maybe one more example if you have time. About the line y equals x, this is the equation of the line y equals x. I'm going to use green this time because it doesn't need to be highlighted. This is a very, very important line. That's the y equals x line right there. Okay? I'm going to use pink for this, y equals x. So we're going to make the same observation again. We're going to use our scientific hat. We're going to pick a point, let's say 3, 0. That's our point F. We're going to try to reflect it about this line right here. It's probably going to be somewhere up here, 0, 3. And try to work this out by yourself so that you can kind of see what's going on. And that's f prime, our image. So let's use our, put on our scientific hat again, and what would our hypothesis be? Our hypothesis says that a point x, y does a reflection, or is reflected about the line y equals x, should become y, x. Notice 3, 0 became 0, 3. There's no negatives involved. Think about this, y equals x. Didn't the y and the x get switched? You can see this quite a bit in Algebra 2 next year. So make sure you get the line y equals x, and we're going to do transformations of inverse functions later on. Okay, so it's going to be very helpful that you know this information. In fact, most information that you learn in geometry will be used in Algebra 2, trigonometry, calculus, and for those of you that are going to go on into college in the science field, it's ubiquitous. That's a nice little word. Ubiquitous means everywhere. Okay, ubiquitous. So let's test a value. Let's actually do some points. Let's draw something. Yeah, everybody likes to draw. So I don't know. Let's draw something here. Here, and it's going to go down to here, and it's going to go to here, and then it's going to go here. Okay. And I'm going to use my fine marker this time. This point right there is -3, -8. That's I don't know, P. This point right there, Q, is going to be -1, -7, and then R. So P is going to be -3, -8, and Q is going to be -1, -7, and R is going to be -2, -4. I hope you can all see that. And so if you rotate it about the y equals x, we just switched the x and the y, became -8, -3. We're going to reflect it about the line y equals x, -7, -1. We're going to reflect it about the line y equals x, switch the x and the y, -4, -2. And so that should be our P prime, our image, Q prime, and R prime, our image. Let's use pink for, orange for this one. So -8, -3, -8, -3. That's P prime right there. And then Q prime is located -7, -1, -7, -1. So we're going to connect those two points. That's Q prime. And then R prime is -4, -2. And there it is right there. That's R prime. And we forgot to find this point. It seems to be at -4, -2.